Our objectives in this lesson are the following. Illustrate the probability distribution for a discrete random variable and its properties. Construct the probability mass function of a discrete random variable and its corresponding histogram. Let's have a quick review of our previous lesson. Classify the following as discrete or continuous random variable. Number 1, number of attendees in a webinar. This is discrete. Number 2, length of teacher's table. This is continuous because length is measurable. Number 3, baby's age in nearest month. This is discrete. Although this is age, it is stated here in nearest month. So we're going to round it off to the nearest month. Number 4, amount of savings. This is discrete because money is quantifiable and countable. Number 5, temperature of a cup of tea is continuous. Since we are going to focus our discussion in discrete random variable, then let us review also its definition. A discrete random variable has a countable number of possible values. Let us define probability distribution. Probability distribution, also known as probability function, probability mass function, sometimes frequency distribution, is a list of random variables' possible values and its corresponding probabilities. Here are the common notations that we are going to use. Capital letters such as X, Y, and Z denote random variable. Small letters such as small letters X, Y, and Z denote random variables' possible values. Capital letter S stands for sample space. It is the list of all possible outcomes of the experiment. And probability may be expressed in the form of decimal, fraction, or percentage. This time, let us discuss the properties of probability distribution. Number 1, the probability that a discrete random variable takes on a specific value is P of X. In symbol, the probability that a discrete random variable takes on a specific value is equal to P of X. Number 2, each probability, the P of X, must be from 0 to 1. In symbol, P of X is less than or equal to 1, but greater than or equal to 0. Number 3, the sum of all the probabilities is 1. In symbol, the summation of P of X is equal to 1. And last one, the probability of a certain event is the sum of all the probabilities that contains the given event. In symbol, the probability that a discrete random variable is an element of a certain event is equal to the summation of the probabilities that includes that certain event. Here are the steps in constructing probability distribution. We will go through these steps as we discuss the examples. First one, rolling a fair die once. Let X be the number shown on top face. Once again, here are the steps. Number 1, identify the experiment. Our experiment is rolling a fair die once. Number 2, identify the random variable. Our random variable is the number shown on top face. Number 3, determine the sample space. Since this is a die, and a die has 6 faces, and each face contains a unique number of dots. Those are 1, 2, 3, 4, 5, 6. This will be our sample space, the possible outcomes. Number 4, determine the values of the random variable. Since our sample space is already quantified, then we will use these values as the values of our random variable. Number 5, construct the table for the probability distribution. X here are the possible values of our random variable. So these are 1, 2, 3, 4, 5, 6. F is the frequency. It tells us how often our random variable will occur. So how many ones are there in a die? Only 1. So there is only one chance that 1 will appear on top face when this die is stopped rolling. How many 2s are there in a fair die? Also 1. Same thing with 3, 4, 5, and 6. Now let us add this up and this will be 6. For P of x, the probability that the random variable will occur, simply get the frequency divided by the total number. So for 1, this will be 1 over 6. For 2, this will be 1 over 6. And same with 3, 4, 5, 6. Step 6, add all P of x. It should be equal to 1. Since these are all similar fractions, we just have to add the numerators. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. And that would be 6. Divided by, copy the denominator, 6 over 6 or equal to 1. Let us continue. So again, here is our probability distribution. So step 7, construct histograms. First, the probability histogram. First step, the y-axis. Next, draw the x-axis. Label the y-axis as P of x, the probabilities. And then label the x-axis as x, the possible values of our random variable. Since we only have one value for P of x, then we are going to use only one tick mark. Label that 1 over 6. For the random variable, the values are 1 to 6. 1, 2, 3, 4, 5, 6. Now, we draw our bar graph. So, for 1, the probability is 1 over 6. For 2, also 1 over 6. Same with 3, 4, 5, and 6. This is our probability histogram. Next is the cumulative probability histogram. So, again, the y-axis. Second, the x-axis. Label the y-axis as P of x and the x-axis as x, the possible values of our random variable. So for P of x, we'll start with 1 over 6. Since this is cumulative, we have to add the previous probability to the next one. 1 over 6 plus 1 over 6 is 2 over 6. 2 over 6 plus 1 over 6 is 3 over 6. 3 over 6 plus 1 over 6 is 4 over 6. 4 over 6 plus 1 over 6 is 5 over 6. 5 over 6 plus 1 over 6 is 6 over 6 or equal to 1. Next, for the possible values of the random variable, again, we have 1, 2, 3, 4, 5, 6. Let us draw the bar graph. For 1, we have 1 over 6. For 2, cumulative, it now becomes 2 over 6. For 3, 3 over 6. For 4, 4 over 6. For 5, 5 over 6. And for 6, 1. Take a look at the graph. It looks like a stair because this is cumulative. So we add up the probabilities. Another example, a fair coin is tossed twice. Let x be the number of heads observed. Again, here are the steps. Number 1, identify the experiment. Our experiment is tossing a fair coin twice. Number 2, identify the random variable. Our random variable is the number of heads observed. Step 3, determine the sample space. For the sample space, let us list down the possible outcomes. Since you are going to toss the coin twice, one possible outcome is having tails and then followed by another tail, or tail followed by head, or head followed by tail, or both are heads. This will be our sample space, TT, TH, HT, and HH. Step 4, determine the values of the random variable. Remember, our random variable is the number of heads observed. So let us count the number of heads in each sample point. Here, we do not have heads, so 0. Here, we have 1. Here, we also have 1. And in here, we have 2. So the possible values of our random variable are 0, 1, and 2. Step 5, construct the table for the probability distribution. The possible values of our random variable are 0, 1, and 2. For the frequency, let us look how many times 0 appear in our sample space. Just 1. 1 appears twice, so 2. And 2 appears just once. Now, let us add this up. 1 plus 2 plus 1 is equal to 4. For P of X, get the frequency divided by the total number. So, for 0, that would be 1 over 4. For 1, that is 2 over 4. And for 2, that is 1 over 4. Step 6, add all P of X. It should be equal to 1. Again, these are all similar fractions, so let us add the numerators. 1 plus 2 is 3 plus 1 is 4. Over, copy the denominator, 4 over 4 are equal to 1. Let us continue. Again, here is our probability distribution. Now let us construct the probability histogram. Let's have the y-axis followed by the x-axis. Label the y-axis as P of X and the x-axis as X, the possible values of our random variable. For P of X, we have here 1/4 and then followed by 2/4 and then 1/4, but we already have 1/4 here. Remember, this is the y-axis. So as it goes higher, the values should get bigger. We cannot write 1/4 again here because 1/4 is less than 2/4. For the x, we have 0, 1, and 2. Let us draw the bar graph. For 0, we have 1/4, so 0, 1/4. For 1, we have 2/4, so in 1, 2/4. In 2, we have 1/4, so 2, 1/4 again. This is our histogram. Next is the cumulative probability histogram. Again, y-axis and then x-axis. The y-axis is the P of X and the x-axis is the X, the possible values of our random variable. For P of X, the first value is 1/4. This is cumulative, so let us add 1/4 plus 2/4. 1 plus 2 is 3, so 3/4. And then 3/4 plus 1/4 is 4 over 4 or equal to 1. Again, for our x, we have 0, 1, and 2. Let us draw. For 0, we have 1/4. This is cumulative, so for 1, we have 3/4. And for 2, we have 1. Again, this looks like a stair because this is cumulative. Let us do extra challenge. A pair of dice is rolled. Let x be the sum of the number of dots on top faces. So we are going to answer this. Let's have the first one. Construct probability distribution. Again, here are the steps. Number 1, identify the experiment. Our experiment is rolling a pair of dice. Number 2, identify the random variable. Our random variable is the sum of the number of top faces. Number 3, determine the sample space. For the sample space, we have many possibilities. Let me explain. The first number represents the top face of the first die. The second number represents the top face of the second die. Here is another possible outcome. The first die shows 1 on the top face and the second one shows 2. Another possible outcome is 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, and until 6, 6. Let us count how many sample points do we have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 is 36. We have 36 sample points. But our random variable is the sum of the number of top faces. So we are going to get the sum of each possible outcome. So starting from here, 1 plus 1 is 2. Here is 1 plus 2 is 3. Here is 2 plus 1, also 3. Then 1, 3 is 4. 1, 4 is 5. 1, 5 is 6. 1, 6 is 7, 8, 9, 10, 11. And the greatest possible sum is 12. That is when both dice show 6 on top faces. So again, our random variable values are 2 to 12. Step 5, construct the table for the probability distribution. Let me do it this way. Here are the possible values of our random variable, the sum of the top faces. And in here, we are going to write its corresponding probabilities. Let's start with the first one. The sum is 2. For the sum of 2, that is only possible when both faces show 1. So only one possible way out of how many sample points do we have again? 36. So 1 out of 36. Next, sum of 3. So for 3, we have 1, 2, and 2, 1. There are 2 possible ways out of 36. Sum of 4, we have 1, 3, 2, 2, and 3, 1. 3 possible ways out of 36. Sum of 5, we have 1, 4, 2, 3, 3, 2, 4, 1. 4 out of 36. Sum of 6, we have 1, 2, 3, 4, 5 out of 36. Sum of 7, we have 1, 2, 3, 4, 5, 6. 6 out of 36. Sum of 8, we have 1, 2, 3, 4, 5. 5 out of 36. Sum of 9, we have 1, 2, 3, 4. 4 out of 36. Sum of 10, 1, 2, 3. 3 out of 36. Sum of 11, we have 1, 2. 2 out of 36. And for the sum of 12, we only have 1 out of 36. Step 6, add all p of x. It should be equal to 1. So since these are similar fractions, we just have to add the numerators. 1 plus 2, 3, plus 3 is 6, plus 4 is 10, plus 5, 15, plus 6, 21, plus 5, 26, plus 4, 30, plus 3, 33, plus 2, 35, plus 1, 36. 36 divided by, copy the denominator, 36, or equal to 1. That's it. We're done with the probability distribution. Let us have letter B. Create probability histogram. Once again, here is our probability distribution. Let's draw the y-axis, followed by the x-axis. Label the y-axis as p of x and our x-axis as x. Let's start with p of x, 1 over 36. Then we have 2 over 36, 3 over 36, 4 over 36, 5 over 36, and 6 over 36. No need to write this because they are already here. For our x, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let us start. For 2, we have 1 over 36. For 3, we have 2 over 36. 4, 3 over 36. 5, 4 over 36. 6, 5 over 36. 7, 6 over 36. 8, 5 over 36. 9, 4 over 36. 10, 3 over 36, 11, 2 over 36, and 12, 1 over 36. That's it. We have the probability histogram. Letter C, find the probability that the random variable is greater than or equal to 9. Again, our random variable is the sum of the number of top faces. Let us recall our sample space. This time we are only particular with the sum that is greater than or equal to 9. And those are 9, 10, 11, and 12. Remember property number 4 of the probability distribution? I'll explain it in this example. So our event here is that the random variable is greater than or equal to 9. To solve for that, we have to get the summation of the probabilities that observe this event. Meaning, we have to get the probabilities that the sum is 9, 10, 11, and 12, and then sum it up. So here is our probability distribution table. Let us start with the sum of 9. Those are 3, 6, 4, 5, 5, 4, and 6, 3. 1, 2, 3, 4. 4 out of how many sample points do we have again? 36. So 4 out of 36. Next, sum, that is 10. We have 1, 2, 3. 3 out of 36. Next, sum of 11. 1, 2. 2 out of 36. And sum of 12, we have 1 out of 36. In formula, it will look like this. The probability that the discrete random variable is greater than or equal to 9 is equal to the summation of the probabilities that it is 9, 10, 11, and 12. So we just have to add all of this. Similar fractions, let us add the numerators. 4 plus 3, 7 plus 2, 9 plus 1 is 10. Copy the denominator. Both are divisible by 2. 10 divided by 2 is 5, and 36 divided by 2 is 18. Therefore, the probability that the random variable is greater than or equal to 9 is equal to 5 over 18. Last one. Find the probability that the random variable takes an even value. Again, our random variable is the sum of the number of top faces. Let us recall our sample space. This time, we are only particular with the sum that is an even value. So those are 2, 4, 6, 8, 10, and 12. Once again, here is property number 4 of the probability distribution. This time, our event is that the sum is an even value. So we have to get the probabilities that the sum is 2, 4, 6, 8, 10, 12, and then sum it up. Here is our probability distribution. Let us start with the sum of 2. And that is only 1 out of 36 sample points. Sum of 4, we have 1, 2, 3. 3 out of 36. Sum of 6, we have 1, 2, 3, 4, 5. 5 out of 36. Sum of 8, we have 1, 2, 3, 4, 5. 5 out of 36. Sum of 10, 1, 2, 3. 3 out of 36, and sum of 12, only 1 out of 36. Due to limited space, I will just add it here. 1 plus 3 is 4, plus 5 is 9, plus 5 is 14, plus 3 is 17, plus 1 is 18. Copy, divided by 36. Both are divisible by 18. 18 divided by 18 is 1. 36 divided by 18 is 2. Therefore, the probability that the random variable takes an even value is equal to 1/2. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Couple plan to have 3 children. Let X be the number of girls the couple may have. We are asked to answer the following. Let us start with the first one. Construct probability distribution. So our experiment is guessing the gender of 3 children for our random variable, that is the number of girls the couple may have. For our sample space, let us list down all possible outcomes. So we are going to guess the gender of 3 children. So it could be girl, boy, boy, and then boy, girl, boy. It could also be boy, boy, girl, 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 boy, boy, girl, 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 boy, girl, or 3 girls or 3 boys. So these are our sample points that comprise our sample space. Now, for the random variable, let us determine how many girls are there in each sample point. So here we only have 1 girl, 1 girl, 1 girl, 2 girls, 2 girls, 2 girls, 3 girls, and no girls. The possible values of our random variable are 0, 1, 2, and 3, meaning no girls, 1 girl, 2 girls, 3 girls. Now let us construct our probability distribution table. So our X are the possible number of girls, so 0, 1, 2, and 3. For the frequency, we just have to count how many times these random variable values appear in our sample space. So 0 appears only once, so 1. 1 appears 1, 2, 3, 3 times. 2 appears 1, 2, 3, 3 times. And 3 appears only once. Add this up, 1 plus 3 plus 3 plus 1 is equal to 8. For the probability, we just have to get the F divided by the total. So for no girls, we have 1 over 8. For 1 girl, we have 3 over 8. For 2 girls, also 3 over 8. For 3 girls, only 1 over 8. And then add this up, similar fractions. Let's add the numerators. 1 plus 3, 4 plus 3, 7 plus 1, 8. Copy the denominator 8. 8 over 8 are equal to 1. That's it. We're done with the probability distribution. Letter B. Find the probability that the random variable is greater than 1. Here again is our sample space. This time we are only particular with girls greater than 1. So those are 2 and 3 girls. So here is our probability distribution table. Let us count how many times 2 appears in our sample space. 1, 2, 3. 3 out of 8. For 3, let us count only 1, so 1 over 8. Let us add this 2. So we have 3 plus 1 is 4. 4 over 8, both divisible by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So the probability that the girl is greater than 1 is equal to 1/2. Last one, create the probability histogram. So here again is our distribution. Y-axis, x-axis, we'll label the y-axis as P of x and x-axis as x. Let's start with P of x, 1 over 8. And then we have 3 over 8. 3 over 8 again, it's already here. 1 over 8, it's already here. For our x, we have 0, 1, 2, and 3. Let us start. For 0, we have 1 over 8. For 1, we have 3 over 8. For 2, also at 3 over 8. And for 3, 1 over 8. So here is our probability histogram. Gets? Our next topic is interpreting probability distribution.